Hi everyone, mechanics of materials. Let's review an interesting problem in terms of shearing stress. So if we have like two wooden plate stick to each other, like with the connection which you can see here, and a tensile force is applied at both ends or at the both ends of our wooden plates. So the dimension of the wooden plate is provided to be half an inch in terms of thickness and 9 inch in width. If we do know what the shearing stress at the wooden plate is, then we want to know what is the tensile force applied at the both ends. So our wooden plates are provided to be a half an inch in thickness and 9 inch in a bits. They are connected to each other, and the shear stress in wood is 1.2 ksi. We want to determine the magnitude of tensile force at both ends. The dimensions are provided, and also these dimensions are provided. Now, to solve such problem, we need to come with the exact cross-sectional area. If you look at one of these connection, you can easily see this is the part which the connections are eh, joined with each other, and as soon as you apply a like tensile force like P here, this is the area which you can have like a shear stress on that. So if the dimension of that area is provided, which we already know, their length is provided to be each part is 5 over 8 inches. Mhm. And then the thickness of plate is 1 over 2 or half an inches in terms of thickness. So these are our area. So if you keep a closer look, you can easily see the area of each of this part is like this part, which is 5 over 8, 5 over 8, two of them, 2 times 5 over 8 times the thickness of the plate, which is a half an inches. And how many of them do we have? It's like 1, 2, 3, 4, 5, 6 of them. As soon as the only note for this problem was to come with the exact cross-sectional area for the connections. And as soon as you have that, you can just jot down the shear stress formula, my bad. And then tau average is nothing but the force over the area, and we are provided with tau average, which is a 1.2 10 times 10 cube, that's ksi, kilopound square inches, and then that's equal to 2 times p, because we have like two force, we are pulling the plates from both ends. That's why we have like 2 times p over, we have 6 of these uh, cross-sectional area, which each of them is 2 times 5 over 8 times 1 over 2 in terms of inch square. And if you do that, do the calculation, it just gives you a tensile force is equal to 5.25 kilopounds. An interesting problem. If we just have the same problem, but just consider we want to eliminate one of this force. So it means, what if we are just pulling the plate, the same configuration, but we have like only pulling a tensile force from one end. In that in that sense, we will increasing the possibility of handling the force by 2x. So that time we will have like P is like a 4.5 kilopounds, because definitely if you pull the plates from both ends, it it can it's just it's more prone to go to failure in comparison to when you just pull it from one end. So And if you pull it from one end, it has more capacity to handling load. That's the point. And if you just pull it from both ends, the force can be handled. It's also reduced. Thank you. We'll solve more problem issues.